You're listening to There Ought to Be a Law, the Center for Auto Safety podcast with Executive Director Michael Brooks, Chief Engineer Fred Perkins, and hosted by me, Anthony Cimino. For over 50 years, the Center for Auto Safety has worked to make cars safer. Hey listeners, welcome to September 24th. Don't take your Tylenol, or take your Tylenol. I don't know. It doesn't really matter. That's not what we're talking about today. Today we have a special guest returning, as always, to the show, Phil Koopman.
Hi, thanks for having me on. We're gonna have fun.
Yes, we are gonna have fun. Fred is out today. He's I don't know what he's doing. I have nothing clever to say right now. I don't think I have enough caffeine yet. Caffeine. That's where I'm at.
Yeah, caffeine.
Anthony, he had an appointment at the Piggly Wiggly. We all know that's what.
Well played. And that's the end of the episode. Phil won. Okay, so the main reason we have Phil on here is because he told us that he can explain to us why rear view cameras keep failing. Because if you listen to the show, it seems 120% of all recalls are the rear view camera fails. And Michael and I have talked about this. Fred's chimed in. Is it that the rear view camera system, which is a safety system, is it tied directly into your entertainment system that also controls your XM radio? Is it just bad design, or all these car companies getting the same faulty product from one equipment manufacturer? But Phil, tell us why rear view cameras don't work sometimes.
All of the above.
Oh,
well, let me give you some details. So the listeners may not know that I'm first and foremost an embedded system guy. And so I stopped counting at 200 design reviews of things like thermostats and natural gas pipeline pressure transducers and valves. If you get it wrong, things go boom. And a little bit of medical and a little bit of work for the FAA. And I've been all over the place. Big, scary power supplies that you do not want to touch. Believe me, you do not want to touch them. Okay, so I've seen all sorts of stuff like this. And among those experiences were cameras, inspection cameras. And so I've done design reviews on the kind of camera that goes into your wall to look behind what's behind the wall board of the plaster. Those are very handy. And also sewer cams. You know, when they take the picture of your sewer, and so they have these big, long, big pipes running down the length of the building to feed the sewer cams back and forth for testing. And I've seen all this stuff. So, having had experience at that, this is going to be the same technology. And so I was kind of surprised because when I do design reviews, you could just, I'll look at the code. It's like, no, I understand the whole system level, because sometimes I've seen problems that are weird interactions because I know how to do electronics. I was a chip designer for a while. So I can do the whole breadth, and I look at the whole breadth and find some weird things, but I also learn some interesting things. One of them is I was a little surprised that most of these cameras are analog. They're not a camera that converts to bits and sends the bits up the pipe. A lot of the lower cost cameras are analog. Now, it's been a few years since I did design like this. Maybe they're digital now, but we're doing recalls of older cars back when I was looking at these things, and the cameras are analog. And I asked why, and they said, well, it's automotive cost, right? Yeah. But it's also, there's a lot of data. And if you send digital signals, that's a lot of bandwidth to get the sharp corners on the square waves down the wire. And you need more expensive wiring for high bandwidth. And so it's not just that you need to have a circuit board and you need to have a chip, you need to send power to it. And there's temperature issues, there's all these things. There's a lot of system level design issues like cost of wire and all this stuff. So I will speculate here, but based on having seen a lot of stuff. One of the issues, and they would have similar issues, that they had problems with the software up in the camera, and they had problems with the wire. They had very similar issues. Also, I own a vehicle that had recalls. The old vehicle that I sold at this point had recall. I don't know if it was a recall or a service bulletin, but they came in and replaced my rear view camera every year, and it would always fail when it was hot. And this is a known problem on that vehicle. And when I looked into it, what was going on was when the metal expanded on a hot day, it would pinch the wires and it would compromise the signal integrity and the camera wouldn't work. Okay. So So let me start at one end and go to the other. I'll give you this background. It's like I've actually seen and touched some of this stuff. You've got a camera, and the camera is cheap because it's automotive. Okay. And when it gets hot, it might have issues. If it has voltage problems, it might have issues, but it's probably an analog camera, especially in the older systems. And then it's sending these high frequency signals. Video, it's like 30 frames per second. There's a lot of dots in a frame. All those dots have to come up the wire. Now, do you want expensive wire, or do you want expensive wire with robust shielding and great signal integrity, or do you want the cheapest wire you can buy that probably does the job? It's automotive. The answer is the cheap wire.
But what's the price difference we're talking about? Because I mean, GM, they're not buying one piece of wire. They're not going to Radio Shack. They're buying tons of it.
I understand this. I don't know the numbers, but it's not a lot. But you have to understand, back in the day when I was designing cryptography for remote keyless entry, I needed 64 more bits of RAM. I didn't say megabits. I didn't say gigabits. I had 64 bits of RAM. They had to make a special chip variant of this little tiny chip, and it was 5 cents. And that was a VP inquisition to spend 5 cents per car. Okay.
Oh, yeah.
Yeah. Jeez. Yeah. You have to understand it's so, and the reasoning is, well, yeah, it's only 5 cents, but if you have 10,000 components, the 5 cents starts adding up, right? That's the logic. And I get it. That's the industry. It is the way it is. So they're going to use the cheapest wire. The cheapest wire they think will do the job, but no cheaper. And sometimes they get that wrong. That they get a little cheaper than they should because it seems to work. But when you get old, when the wire gets 5 years old and it's a super hot day and somebody didn't get the clearances right on the metal around the wiring trace, which is part of the floor of the back of your SUV or whatever, and it squeezes and all these things interact and you get a compromise of signal integrity. So one of the reasons for rear view camera problems that I know for a fact, because my car had this, was just went a little too cheap on the wiring trace back out to the system. That's one. And of course, cameras can fail, but that's hopefully not systematic. Now you get those wires, and it goes up to a computer, and it's not a safety integrity computer. It's the infotainment system, and we've seen recalls for those computers wearing out or being lower quality than others. Some companies more than others, right? But it's worse than that, because you've got video coming into a digital computer circuit board. That's just asking for trouble. You have high frequency video messing with the signals in a digital system, and the digital system messing. So you've got these high speed gigahertz digital stuff right next to some video. There's interference. So you need shielding. Shielding costs money. You need to segregate the circuit board, so the analog part is on a different part of the board from the digital part, and you have to put these little like moats, complete with crocodiles and stuff, between them to separate them, and that costs money. I'm having a little fun there, and maybe a metal box, but metal boxes cost money. And so you have this mixed signal board, and it's catching the video, and then what do you do with the board? Well, the rest of the board is typical consumer grade electronics, possibly. Hopefully it's automotive grade, but it's a temptation to go cheap and consumer grade, and we've seen problems from this, so it depends on the company. But even if you go automotive grade components on the circuit board, you're running cell phone OS, which is not safety rated, and the software, and you're running other software on the same thing that interferes, and you also have the FMVSS, Michael remembers the number, I don't, for review cameras also has a minimum time to image. You put it in reverse. You need that image right now, and 30 seconds is not the answer. Well, these operating systems were never designed to power up and instantly display a video. So you have to jump through a bunch of hoops to get the display up quickly, and if that delays, a bunch of recalls, or simply that took too long, and that's a software integration issue. Okay, so it's more not a question of what went wrong. It's more a question of what is there not to go wrong. Everything can go wrong end to end, and it's sort of fragile technology to begin with. I'm not saying it's inherently unsafe. I'm just saying it's if you have cost pressure and all these engineering things and trying to get that right, it's really easy to make a mistake. And a lot of the mistakes are not this guy did something wrong. It's more, well, this guy didn't realize that if he didn't leave enough clearance to squeeze the wires, and this guy didn't know his wires were going to be squeezed, and they saved a little bit on insulation because it seemed to work fine in the lab, but they didn't test it on the 100-degree day, and all that kind of stuff. It's just really hard. This is a system integration issue, and system integration, system engineering is really hard. Cars are one of the most difficult system engineering problems out there, and we're just seeing signs of this kind of thing happening.
So I have three takeaways from this. This is the typical automotive industry thing where it's like we don't want to spend an extra dollar.
They don't want to spend an extra dollar, and the economics of the situation force all the players down that path.
Yeah, I don't understand.
This is not this is not a lack of moral fiber. That's the business. I want to be clear about it. That's the business. Yep.
Yeah. No, that's some MBA who came out and said, "Hey, I learned how to use Excel and I can save $1 here."
Or it's consumers buying the cheapest car.
But
where do you think that cost pressure comes from, right?
No, but when we're talking like $1 or a couple dollars, you're spending $20,000.
It's $1 times 10,000 components. That's $10,000. That's the logic, right?
Right.
And so the question is, you spend the money where you need to, but you really have a gauntlet to run through if you want to spend money. And it's easy to think you're doing the right thing, but being a little too cheap because something bites you that you didn't expect, right? That's why it's such a hard system engineering problem. So it's not. Everyone loves to make fun of the auto companies for pinching pennies, but there's a reason they do it. And I look at it as a very challenging system engineering problem and safety engineering problem, how to make sure your system meets the requirements, how to make sure it's acceptably safe without spending money where you don't need to. I think that's a reasonable way to put it. And it's very easy to get those trade-offs wrong, even if you're well-intentioned. Now you add to that the MBAs who are beating on you to reduce cost beyond the point you should, and that's where we see problems. I don't know if that's the dynamic behind the cameras or it's just a systemic challenge. But for some safety things, we know for sure what happened was they got beat on to reduce the cost past where they should have.
Right. So that also just fires in my brain saying, well, we're moving towards autonomous vehicles and ADAS systems. If they can't get because in my mind, the rear view camera is a known problem. The first one came out in the mid 50s. Like this shouldn't be something totally unknown.
Everyone knows how to do it. Everyone knows what the challenges are. And it's not you're not smart enough to do it. It's not that there aren't established things. It's rather living on the razor's edge of cost cutting to the point that it still works, right? That's the challenge.
Right. So then I look towards like ADAS systems, automatic emergency braking and whatnot. If they're going to cut prices and costs to the bone on something like a rear view camera, how does the consumers get faith that they didn't do the same thing with AEB or lane keeping or, a level 3, level 4 system? Like
we're getting there. There's another dynamic. The other dynamic is that what you see is the advanced features show up in the expensive cars first, the ones with more margin. And so if you're putting out 10,000 cars with a feature instead of 1 million cars with a feature, and it's the high margin car, you can afford to be a little more relaxed on cost. Now, believe me, it's not Scrooge McDuckian, time around your money. That's not what's going on here. But if there are like the first radars that went in the car, one of the engineers who worked on the first radars, and I don't remember enough specifics, so I don't want to misattribute, but they basically said the inside joke was buy a radar, get a car free, because the radar. but they only probably sold 100 cars like that, and the point was to get the radars out on the road and get experience, and it was an engineering cost. Okay, cool, and so what you see is because those radars were super expensive, more than the cost of a car. So what you see is that these systems, they start with high end and there's less cost sensitivity because it's proof of concept and they're trying to get the technology out there. And then over time, there's pressure to cost reduce over time. And over time, partly it's because you're maturing the technology, partly it's because you're trying to extend it to the low range. So when I was involved in remote keyless entry, so you click the button and the car doors unlock, I did cryptography back when that was a novel thing and it was really expensive and it was very challenging. But my understanding of the contract was, and I'm not going to use actual numbers to protect the guilty here, but I'll use a made up number. This is a made up number, but it's not so different. It's like, well, it costs us $10 to produce it, and the car company says, great. The first year you can sell it for $9.95. And next year, you're going to sell it to us for $9. And the year after that, you're going to sell us to $8. Have fun with that. And what happens is the company spends all the time figuring out how to cost reduce and still meet the specs over time, and it gives you some time to do that. And while that was happening, the order volume ramped up from a few cars to a bunch of cars, and so that's the industry dynamics. The only thing I'll say is $10 was more than the budget we actually had, and that was for both the transmitter and the receiver. It was
Wow.
crazy. It was crazy. All right, it was crazy. But you add it in, you multiply by 10,000. It's a lot of dollars, right?
Right. But then I also see this like as what you're saying, basically moving this towards the lower cost vehicles as ADAS systems as they progress down. There'll be that cost cutting.
Well, it's a cheaper car. And the same box costs the same money. It's a bigger slice of the pie for a cheaper car. So there's more cost pressure. So as what you'll see is as the technology matures, you figure out ways to make it less expensive, partly volume, partly redesigns, being smart about design. Now that you know what you're doing, you go in and optimize the design. And that allows you to ramp it out to bigger fleet sizes. So with AEB, when they're saying, well, we're going to force a better AEB with the regulation that I think is that getting pulled back? Who knows these days?
We don't know the outcome yet, but it's in review, right?
Yeah, and the argument there is it's expensive and it's we need more time. But some of that is, well, if you had started earlier, you'd have time. I don't know if I'm stealing your thunder on another piece, but it shows up here. If you started early, you had more time, but it is a chicken and egg kind of thing that you need the volume to get price, but to be able to put it in, you need the price, but you don't have the price because you don't have the volume, right? So
I wonder if there's a way to kind of address some of the more glaring issues. Say NHTSA went back and reviewed FMVSS 111 that applies to rear view cameras. And, are there ways to mandate manufacturers to use, cables that aren't going to be impacted by things that cars are going to experience, like heat or isolating the signals so that you don't have the interference problem? Is that something that can be done by regulation? Is that a little too, complex a problem for NHTSA to address, and something that maybe SAE standards or something are better suited for?
Well, to be clear, not all cars have this problem all the time, right? So it mostly works, and people are just getting caught at the margins. I mean, I know Anthony just loves making fun because it hits everyone, right? And it's just a sign that people are still learning how to skate the razor's edge here, right? NHTSA kind of doesn't roll that way. They have more performative standards than design standards, and given the system we have, it is a system we have. SAE could have more technical standards for like signal integrity under heat. NHTSA could, however, say, "Hey, we're seeing a lot of cars with heat now." There's this sampling bias that it happened to me, so it's on the top of my mind. I don't know if heat is always, but if they're noticing a pattern that all these cars fail under heat, they could add FMVSS. They could say, "Oh yeah, and by the way, you're going to run the test at 110 Fahrenheit, right?" They could run a test to test for the environmental conditions that have been known to provoke these things. Aging is tough. Accelerated aging is sort of tough. It's sort of beyond what NHTSA typically does.
Yeah.
But there could also be SAE standards where they say, "Hey, everybody, let's get together, put our heads together, because no one wants a recall." And let's try and find some engineering techniques that preserve cost effectiveness, but really reduce the risk of a recall. Recalls cost money, and maybe always spending 2 cents more, even though you're not sure you need to, reduces the risk of a recall. Maybe that's the right math, and that's an SAE kind of thing.
Okay. And I'm also wondering, does NHTSA have an argument here, or is there an argument here that we should be separating safety critical systems from infotainment systems and making sure that they're not able to interact with one another in a way that's detrimental to safety?
Well, there's a bigger trend, because we've also seen recalls. Set aside the rear view camera. It happens to use the infotainment screen because screens are expensive and it needs a screen.
Sure.
Okay. But there's also the infotainment running both entertainment and running critical functions, most notably when things like the windshield wiper command shows up there and when the malfunction indicator lights, the dummy lights, idiot lights, right? When they show up on the screen and the screen's not working, now you've got a safety recall.
Yeah.
And I haven't dug into this in a while, but last I checked, Android wasn't ASIL D, right? I mean, it's these operating systems. What's their safety rating, and what's the argument that they can isolate the safety functions from interference from the infotainment functions? And the answer is NHTSA does not require following safety standards, so it's not a question. But every time a company tries to save money by using a non-safety operating system because it's convenient for infotainment, they're increasing the risk they're going to have this kind of recall because of interference between infotainment and the safety functions. We see the recalls happening, right? That's another set of recalls. And the companies are willing to go that way because cost.
I see them. They're using a different OS for companies that use like the tachyometer and the speedometer, because that has to be accurate.
Well, so what we used to see before the one screen does everything vehicles is you'd have an infotainment screen and you'd have a dashboard screen, and those dashboard screens would run a safety qualified operating system.
But that's the thing is, I mean,
or at least that in the good old days when speedometers really work, they'd run a different operating system. Now, I had a grad student who managed to crash one of those once. I was driving on the Ohio Turnpike, and my student was taking data, and he messed up, and my dashboard crashed, and I had to go to a service area and reboot my dashboard. But that's because he was messing with the OBD port, so we brought that on ourselves.
That's a fun time. As you just wet your fingers, stick it out the window. This is, I think, how fast we're going.
Yeah. So his name was Aaron. I'm sure Aaron remembers that.
So.
But he wasn't trying to crash the car or anything. He was just trying to collect data, and he saturated the bus by asking for too much data. That's what it was.
That's hilarious. So from an engineering point of view, pretend you're working in these systems again, what would you have needed in terms of regulations or some sort of encouragement so that you could have that opportunity to say, oh, we need shielded cabling. We need, a better Faraday cage around this so we don't have interference or whatever it is.
Well, there are two methods. And typically, especially in automotive, where you have this cost pressure, you're probably going to get it wrong until you learn a lesson. You're going to cost cut, and the traditional OEMs are pretty good about trying to. They go down to Death. They take road trips to Death Valley, and they take road trips to the Rockies, and they shake out a lot of this. They'll say, "Oh yeah, there's a defrost problem because we were driving in the Rockies and we had this problem." So they're pretty good at finding most of that stuff, just by internal. Yeah, we have to test it because we don't want it to cause a recall. So that's part one. From a safety mindset, if the rear view camera flakes out while you're in Death Valley, and you turn off the car and turn it on again and it works, you don't say, well, it worked the second time. You say, why did it flake out?
Right.
And so the failure mode you see in the corporate culture tends to be, we're in a hurry, we've got a deadline, it did it once, we can't reproduce it, so we're going to ignore it. And that's the kind of stuff that bites you later. Now, I don't know that that's the case for all of these, but I strongly suspect I've seen plenty of examples of something went wrong, they couldn't reproduce it, and they said, well, never mind, we're just going to deploy and deal with it later. And then down the road, you end up with a recall or don't, but there's a high risk of recall. That's part of it. Part of it is just saying, well, the last 5 times we had a heat problem, maybe we need a heat test. What do you think? That's part of it. And a lot of this is just internal quality stuff for the car companies, because we do have a recall system. It's bad when your backup camera doesn't work, but it isn't like it's going to cause your car to explode. So it's the kind of thing that if you have the recall, it's more a matter of money than it is of extreme damage. Now I'm not saying the backup camera should work, but attentive drivers will say my backup camera isn't working. We hope that they pay attention more to the surroundings and so on. And so I just knew on my old car that it was a hot day. It was over 95. My backup camera was just not going to work. So I'd do a walk around on my car and make sure everything was clean. But not every driver is so responsible.
Right. I mean, thankfully the mirrors will still work.
Yeah, and the mirrors. Well, it's an SUV, so you have so the dangerous part is right behind the rear bumper because you just can't see anything there. That's the issue.
Yeah, a friend has I think it's some sort of Toyota Land Cruiser, really clever backup camera where the rear view mirror is a camera and you're seeing a video screen, which is great. And I'm like, what happens when that fails? Because, I spend a lot of time
Yeah.
talking to Michael Brooks.
Yeah.
And he goes, look at this. And like that little switch where you flip it for like daytime, nighttime, it goes back to analog mirror. And I'm like, oh,
Okay. Well, that was
great.
thoughtful. That was smart. Yeah.
Yeah. I was like, that's
And
great.
when my first car, because I was a poor military officer, they don't get paid very well the first 4 years. I had to buy a car where the passenger side view mirror was optional, but I bought one and bolted it on. Right. So those are the days.
All right. Well, I feel a little more satisfied understanding these rear view camera recalls. I understand a little bit more about how detail it comes into, and it always just comes down to the penny pinchers.
It's down to the cost pressure. Yep.
Right. Hey, but listeners, you don't have cost pressure, do you? Go to autosafety.org and click on donate. There you go. But Michael, we have a new people at NHTSA now. We have your buddy Jonathan Morrison is now the head of NHTSA. And he during his confirmation, he was asked, why do you want to do this? And he said, I believe the motor vehicle has been instrumental in the success of the American public over the past century. Ready access to car or truck greatly expands our personal, professional, and recreational horizons well beyond any other transportation technology, and has much to do with the ability to achieve the American dream through upward economic mobility. He didn't talk about safety at all. He didn't talk about, he just very aspirational, kind of almost 1950s-esque, the highway is the future.
Yeah. I mean, that's kind of what we've been hearing from Secretary Duffy along the way as well. And, we're interested to see what happens here. There's a lot of issues facing NHTSA right now. In comments recently, Jonathan Morrison, the new NHTSA administrator, has heavily focused on technology and levering technology for safety. Unfortunately, a lot of that is wrapped up in autonomous vehicle safety. We continue to hear about autonomy constantly from the agency as though that's going to swoop in and save us all in the next few months. And, it's not the technology.
Not happening.
Yeah. It's not the technology that is, that needs to be unleashed. The administration talks about unleashing innovation, and they talk about it in the context of taking away barriers to autonomous vehicle manufacturers. What they really need to be unleashing is the technology that can address, what we're looking at on the roads right now. The problems that we see, speed, distraction, and impairment, are three of the major killers of people on our roads. We've got both automatic emergency braking and intelligent speed assistance that can assist with speed. AEB, as we just discussed, is still kind of in limbo over at the agency. Intelligent speed assistance has not been promoted by the agency virtually at all. They have really not moved forward on preventing Americans from speeding. And NHTSA is really in virtually every press release they've put out in the current administration, they've referenced law enforcement. Now, NHTSA has long been a source of funds for police activity around areas like, seatbelt campaigns, drunk driving campaigns, getting money to law enforcement through various grants and other agreements to make sure that they, are on the road trying to enforce and enhance safety of drivers. But enforcement is, it's somewhat like spot checking. You're only going to address certain people. Some people aren't really changing their behavior if there's greater enforcement, as we've seen a lot, as we've talked about some of the people racking up speeding tickets in DC and New York in the past. So enforcement is an important part of the mechanism. But where I see NHTSA, what I don't see them talking about, they talk a lot about autonomous vehicles and a lot about law enforcement, but they're not talking about the technology that we have, like ISA, like AEB, to address speed, like effective driver monitoring that can address both distracted driving, which is a massive killer of people on our roads, but also some of the automation complacency we're starting to see in ADAS systems as people become, more willing to use those convenient systems. They're still not really safety systems, and they may never be. We're just not sure. But driver monitoring is something that's been on NHTSA's plate that they should be researching and should be getting standards out to make sure that the driver monitoring going into vehicles is effective at preventing distraction, at preventing complacency, and making sure that drivers maintain focus on the vehicle operation. And then also, we've seen the failure of NHTSA to move forward effectively on alcohol monitoring, which, could detect and prevent drunk drivers from getting on the road, as well as, we think driver monitoring can play a role in that as well. We saw, I don't think we covered it a couple of weeks ago, but, GM applied for a patent to use some type of driver monitoring to get elderly drivers who are losing their capabilities off the road. We think that same kind of technology could be used to monitor all drivers, to make sure they're not distracted, to make sure they're not on drugs weaving in and out of lanes, to make sure they're not driving recklessly for the conditions in which they're driving. So our main concern, with NHTSA as it moves forward under this administration is, are they going to move to get these technologies into vehicles that are available and are, going out into vehicles en masse to make sure that they're working right for safety? Are they going to focus on that and really try to address the injury and fatality numbers we're seeing on our road? Or are they going to focus on, AVs, which are a shiny object now and aren't going to do anything for safety, in my opinion, for decades down the road? And that's an open question. So, that's what we'll be watching for as Morrison continues to lead NHTSA in the current administration.
Well, let me jump in there. So everything you said, Michael, makes sense to me. Let me add another layer to that. Every once in a while, I just want to do a social media post saying, guys, the S in NHTSA stands for safety. You remember that, and
Thumbs up.
And to be sure, the rank and file folks at NHTSA totally get that. This is more of a leadership direction thing. I want to be really fair about that. But what we see is the following sort of rhetorical cycle. They say, well, the car companies want to sell things that want to do things that sell cars, and all the technologies Michael talked about don't sell cars; they just improve safety.
Yep.
Right. So that's part one. Part two is you do not need autonomy to be safer. Forgive them. I'm virtual Fred, so I'm going to rant occasionally, but I hope that they're relevant. Back in 1985, I did some digging. Back in 1985, the UK was a little bit worse than the US on safety. Although their drunk driver rate then, they just finished a drunk driver campaign in the early 80s. Their drunk driver rate then was lower than our drunk driver rate is now. All right. And ours has come down. All right. So in the 85, they were about the same. But since then, the UK is 2.5 times safer than we are. We got twice as safe and they got 5 times safer. And automated driving had nothing to do with that. So people saying, well, only the robotaxis can make our roads safer is ridiculous. The UK just finished the journey along with all the other high income countries in Europe. They all just finished that journey that they're all way safer than we are. They started at the same place and automation wasn't relevant. So you can do it. Now, the next piece is what the cycle you see is, well, yeah, all that drunk driver monitoring, people don't want their freedoms being trampled and all the other excuses. And I have some, I'm not keen on being monitored for drunk driving because I don't drink at all. I don't want to spend the money, but there is a discussion to be had for sure. I'm not hard over on you should do all this stuff. There's a discussion to be had, but we're not even having the discussion. Or you're having instead is, yeah, but no one likes that. So let's let the shiny object save us. In the rhetorical cycle, it's sort of a vicious cycle. You say, well, clearly robotaxis will save lives because 94% of mistakes are due to human error, which is completely false. But that's still, I just was at an event last week where some CTO said that on stage. And I just did everything I could to prevent from shouting bullshit in the
you should
audience. Well,
Boo.
I was supposed to be well behaved. It's
That's
autonomous.
why I don't get invited.
I was supposed to be well behaved, and I try. I have my weak moments, but I was, but it's like, come on, guys. I thought we put that one around. So, but what they'll say is clearly automated driving will save lives. Therefore, the regulator's job should be to enable rather than stifle innovation, because we know it'll all save lives, where there's no proof that it's really ever going to save lives. It's a convenience feature, as Michael said. Even the robotaxis jury is way still out. And everything you hear about we're already saving lives is more marketing than it is reality. But the leadership in NHTSA can hide behind we know technology saves lives, so we're going to enable technology of the kind our regulatory capture constituents, the car companies, want, right? And that means more automated driving, more robotaxis. And we're going to ignore all this other life-saving stuff we could do that the rest of the world wants to do because we're going to double down on robotaxis. So it's really tough. And the way to break the cycle is to realize supervised automation is a convenience feature, not a safety feature. Maybe someday, but not any day soon. And robotaxis, jury's still out on whether they'll ever save lives. And by the way, to make a dent in the 40,000 plus a year, there's going to need to be millions of these things, and that's 10 years out plus. That's not happening.
And you've got to get humans off the road, right? At some point, if you really want to achieve these awesome safety gains, you've got to get, and you're going to have to displace the human drivers who.
Well, Michael, are you advocating that pedestrians should not all be allowed to cross the road because that's what gets them killed?
Yeah, no, just the human drivers in the cars, right?
If you said people off the roads, I'm really worried about the pedestrians with this technology far more than I'm worried about the people in the cars.
And that's what's there's a freedom argument there that I think is even more powerful than some of the nonsense we hear from the people who want to drink or want to speed. I just want to drive my car.
But how drunk do you want to be when you drive it?
Yeah, I don't know how that's going to work at that point. And forgetting all the other issues, like out in the middle of rural America, just there's a lot of other challenges to getting automated vehicles on the road, like communications networks and keeping those vehicles connected, and this idea that all this is all going to happen at once. We're going to have autonomous vehicles saving us in the next 5 or 10 years is nonsense.
Well, the average car is over 12 years old now. So just on an age out, it's at least 12 years before half of them are autonomous. I mean, they're just, everyone who thinks this is going to happen by next Tuesday is just not paying attention. This is a multi-decade process, and there's a lot of ways for it to go right, but there's also a lot of ways for it to go wrong. This is a 20-year kind of thing, not a 2-year kind of thing.
So first off, I don't believe this whole argument that safety doesn't sell. You go into any Toyota dealership and they have these massive banners hanging up. Toyota Safety Sense version 3. And they advertise the hell out of that, and they're they're the largest automaker in the world. So, but that's could be my opinion. I don't work in marketing. But the next thing is you talked about how the UK they've become.
Do you know who the target market was for Toyota Corolla? I think it was. No. It was like little old ladies, basically. And so
Toyota Corolla.
This is back when I was doing the Toyota unintended acceleration. They were all little old ladies who were having crashes. And it's like, why? And some folks would say, well, it's because they're old. Well, that's not it. It's because that's the demographic for that vehicle is little old ladies. That's basically who buys them. And so safety sells to certain market segments. I mean, I bought my car on safety, but it doesn't sell to other market segments.
Sure.
Yeah, like 25-year-old men.
So me and little old ladies like safety. I get it.
I have to. So I drive a Volvo. I walk into the Volvo dealership, and I'm talking to this guy, and I'm like, I'm not your usual demographic. And he's like, no, you're not my usual demographic.
He just because you approached him right away and said that.
Well, yeah, because they have a reputation for not being middle-aged white males.
Right. That's hilarious. But you mentioned how the UK has become 5 times safer. What's they used to be, and 2.5 than the US rough numbers. Right. Yeah. So what was the big change? Because I know in the UK, their driving test is a lot more difficult than in the US. Did they change it at that point, or has it always been that thing?
Well, it was a multi-decade journey.
But like, what was there some major changes or
there's no secret sauce.
No
Well, first of all, they had just finished getting drunk driving way better.
Mhm.
That was first step, and then
They joined the EU, which has to be part of it, right?
which probably helped, yes. But better driving tests. I mean, our driving tests in the U.S. are ridiculous compared to what you see in Europe, right? So better driving tests, better type approval for cars, a little bit more rigor on the standards. I mean, and Euro NCAP is stronger than NCAP right now, right? But also road construction standards, traffic calming, better designed roads, lower speed limits. Vision Zero, remember Vision Zero? That's a European thing, right? So it's just a bunch of stuff that added up. In the US, now we have folks in DC talking about complete streets and safer road strategy and all that other stuff. I mean, this is the kind of thinking we're talking about. But even in the U.S., if we were to make it less socially acceptable to drink and drive, that would be something we could do. If we were to make it less socially acceptable for distracted driving, which is sort of like a 10% kind of problem. People think it's a 50% problem. It's more like a 10% problem, but that doesn't mean it's not a problem. It's a problem, and it's probably growing, right? But what do we have? We have speeding, we have distraction, we have driving drunk. Those are the big drivers, and dangerous streets, roads that are not necessarily designed to. You have these low speed limits with these streets that look like you can drive 50, and then you have these laws that says, well, if everyone drives 50, screw it, we're just going to increase the speed limit.
Yeah,
right.
How do you expect that to end safely? You don't. We could have safer streets if our country took road safety seriously, and we just don't want to. It's that simple.
Yeah. Yeah. Another thing UK has, I think, is better enforcement of people who are speeding and breaking the law. Like the penalties and the structure of the system. Licenses get taken away a whole lot easier over there, I think, than in America. Maybe that's because we're a much larger country. We've got a lot more. We need cars, I think, a little more here.
It's hard to live here without a license. That's a reality. Yeah. Right? And so, but the important thing is people always want a silver bullet. And the answer is not a silver bullet. It's the whole system. You have to ratchet up safety by improving everything all at once. Right. And that sounds like a lot of work.
Yeah.
And it's going to upset a lot of people.
Well, it's what's needed. I mean, I would just love to have an improved driver exam, because I see some people out there and I'm like, oh God, I'm going to die.
Well, we've decided as a country that we're okay with 40,000 people a year dying, and we're willing to make incremental improvements despite other countries doing better. I think it's harmful for companies who are trying to make a profit to come in and say, oh, we've got a silver bullet, we're going to solve that. Right. Because then it takes the pressure off. Oh, well, robotaxi is going to save us, so we don't need to worry about we don't need to worry about drunk driving because robotaxis. And 10 or 20 years are going to go by before there's enough robotaxis to make a dent in that problem. And
if it makes a dent.
We're going to suffer for 10 to 20 years. So I really worry about companies promising a solution that's going to solve everything because it distracts us. It gives us an excuse to not work on the hard problems.
Yeah, it's very typical tech bro nonsense where here's something shiny, whereas there's simple solutions here. No, there's nothing we can do about that. But speaking of highway deaths, NHTSA has reported a sharp drop in traffic fatalities for the first half of 2025. Early estimates of vehicle traffic fatalities in the first half of 2025, a substantial 8.2% decline in roadway deaths. Now, Michael, is this because perhaps the current administration is like, hey, let's get rid of people who count things?
I have no real explanation. I hope that
Anthony, you can't do that to me when I just took a drink.
This is how I time it.
If you guys saw the video, it was really entertaining.
There's no real explanation provided by the agency, and these things take time, right? This is early estimates. I hope this is an 8.2% decline in roadway deaths. Really do, because that would be the most significant drop we've seen in a long time, certainly since the pandemic. But NHTSA, and if we were doing gaslight illumination this week, I'd be giving it to NHTSA again, because they say that these preliminary figures are encouraging and reflect NHTSA's close collaboration with state and local partners, especially law enforcement, to improve safety on our roads. Now, I've talked a lot about how NHTSA under this administration is giving law enforcement a lot of credit, but we don't have any information that suggests that traffic enforcement has been up under the new administration. We don't have any data to support the assertion that increased enforcement has resulted in increased safety on our roads. So I'm not really sure where they're getting that. It seems more like fluff than actual hard data that lies behind that. I would go so far as to say I don't think that is the reason, but it's probably too soon. It normally is going to take at least 6 months to a year after the end of the year before a real analysis can be conducted of each crash to see what the factors in those crashes were and what the causes of reduced fatalities were. So good news, we think, but it remains to be seen once the numbers are really crunched at the end of the year, if these are accurate. We know that there have been a lot of cuts over at NHTSA. We're not exactly sure where. We know there have been a lot of cuts in states, money flowing to states from NHTSA. And we're not exactly sure where those are either because of a lack of transparency for the administration. So I think there's a non-zero chance that there may be some data deficiencies going on here that could have been caused by some of the administration's actions related to reducing the size and scope of NHTSA. So this is one where we will have to wait and see to confirm whether the numbers are actually good.
All right. Cautiously optimistic, we'll say. Now, Phil, you mentioned you have a Volvo, and any chance it's an EX90?
No, no balls chance.
Lucky you, because this is fascinating. An article from Inside EVs titled "A Dumpster Fire Inside a Train Wreck: Why Volvo is Replacing Every EX90 Central Computer." So it seems what they did is they put out this computer system that doesn't work, and so they're replacing all of that with their latest model. And quoting from this article, this is an amazing sentence, or part of a sentence, and quoting, "and that it's easier to replace the original computer than to build bug-free software for it." There's no such thing as
I read it
software.
a little differently, but this is a big deal, right? So it's
huge.
pretty well known that the original Volvo EX90 was well, okay. I love the title. It's a train carrying a bunch of dumpster fires on the flat cars, right? That's what they're saying. I don't have that opinion. I don't own one. I haven't used it. I don't have an opinion, but this has been circulating around. I read it a little differently. All the car companies are having trouble with software integration, with doing software. They're all having. This has been, we saw the head of Volkswagen get fired over this, right? And that was years ago. This is an ongoing dumpster fire for the whole industry. They're struggling. Now, some friends at Volvo informally told me the new thing will be fine. The old one was a mess. The new one will be fine. We'll see. I hope that's true. But I don't think they're getting rid of the old computers because the old computers are broken. I think it's a mistake to think that the old computers were broken. What I think happened was, and this is just speculation, sort of knowing how the industry works, that the new version has a new computer because newer technology, whatever reason. Maybe the old computer didn't have enough memory, and so they had to jump up and down to smash all the software into a small enough thing to fit, and it caused problems, right? So the newer computer is better. But they decided that taking the new software, which is not a dumpster fire, they say, and squeezing it onto the old computer just wasn't feasible. And so rather than having the new software and trying to backfit it onto the old computer, it was cheaper to just throw away the old computer. So now you have the same computer on the old cars and the new cars. Just trying to move the new software onto an old computer, which has less memory and it has other issues, right? It's slower. Wasn't going to work out. So it wasn't that the old computer was defective. It was rather that the old software on the old computer was such a mess and the new software wouldn't fit onto the old computer. And so rather than trying to fix the old software, they're throwing away the old software to use the new software. But by the way, new computer has to come with it.
That's amazing. I can't imagine the VP in there going, "Wait, what? You You want more than 65 bytes of memory?"
Yeah. Well, so here's the question. The question is, how many did they really sell? And if they only sold a few hundred, then why would you spend millions of dollars trying to port new software onto an old computer when you could just toss 100 computers at it, right? So
Yeah.
it's an economic thing.
Right. Hopefully, it's an easy replacement for existing Volvo EX90 owners.
Well, it's pretty common that they'll have a wiring harness with a connector and they'll have a physical space for the box. And they'll say, you get to put in a new computer, but you're not allowed to change the wiring harness. You're not allowed to change the box. So hopefully this is just a plug-in replacement. And the new computer and the old computer look the same from the outside. That would midlife upgrades. That's really common. So in that case, then that strategy wins if they did that.
That would be great.
Yeah. I think Tesla's doing something similar in a lot of their vehicles for the full self-driving folks. They have to replace the computer.
Was this up to hardware 4 as opposed to as opposed to whichever hardware was going to be for sure?
Yeah.
Hardware 2 was going to do it everything.
I'm making fun of it, but if Tesla goes out and replaces the computer, good on them. That's what it takes. Yeah.
Yeah, I think they'd also have to replace their cameras because they've changed those systems as well. That's what I'm curious is because that software was so tightly coupled to the existing hardware on it. It's
Well, the old FSD software was component-based machine learning, and the new one's end-to-end. So it's a completely different software system.
I don't see it happening.
Yeah.
But with that, I think it's time we have to jump into recalls, unless Michael has an objection. And
No.
by looking at him, he does not.
Have I ever objected to jumping into recalls?
No. All right. First one up, Hyundai, 568,580 vehicle, the 2020 to 2025 Hyundai Palisade. Something with your seatbelt. The seatbelt buckle assembly may have been manufactured with out of specification physical dimensions.
Yeah, I mean, this is something we've talked about today. Temperature problems. It looks like the seatbelt buckles aren't latching under cold ambient temperatures. So that's a really bad thing. Obviously, if you're not latched in appropriately, you are not protected in a crash. We know that, half the fatalities that occur and even maybe a little more than half the fatalities that occur on the nation's roads every year are people who don't have their seatbelts buckled. If your seatbelt's not latched and you think it is, you might as well not be buckled. So this is a pretty big problem. And owners, they don't really give you any information here. They do actually. Hyundai advises occupants to fasten the seatbelt firmly into the buckle with a quick and direct motion. And once buckled, pull on the belt to confirm the seatbelt is fully secured. So everyone out there with one of these vehicles should be doing that. It's basically the last 6 years, 20 to 25 Hyundai Palisade. So everybody who owns one of those should be really focused on the buckling process when they get in the vehicle until November, when it looks like you will get a new seatbelt buckle latch.
Next up, Toyota, 591,377 vehicles, the 2023 to 2025 Highlander, the 2025 4Runner, RAV4 Camrys, all 2025 years, RAV4 Primes. It goes on and on and on. Something called a Toyota GR Corolla. Ooh, that sounds fun. What do we have? This is the long. Oh my God, it keeps going to Toyota Venzas, Toyota Tacomas, the Lexus LS. Oh my God. Yeah. If the vehicle is driven without a working 12.3-inch monitor, is this a rear view camera thing?
No.
Okay, good.
I don't think there was a rear view camera issue, but it does involve the multimedia screen and some things like that. It's basically unnecessary data is being written that causes the memory device in the system to degrade or deteriorate earlier than it's supposed to. And then that basically kills your monitor.
Is this a flash wear out problem? Flash memory wear out?
It really sounds like that, but I don't know.
Yeah, it says due to the improper programming of the combination meter, unnecessary data is repeatedly written to a memory device.
Oh, that's it. Yeah.
Combination
let me, since I'm here and I used to be a super designer, let me explain this. So when you have a flash memory like a USB memory stick or a solid state drive, you only get to write the memory values so many times before you wear it out. It has to do with there's a insulation layer and the electrons punch through the insulation layer, and if you do it enough times, the insulation breaks down and it's dead, right? And when you're an embedded system designer, one of the things you do is to make sure not to beat on the memory locations too often. And so if you have some data and you say, well, we're going to update this clock value, this data value once per second, there's a lot of seconds in a decade and you wear out the flash memory. And so you have to do things like say, well, we're going to keep it in regular memory and we're going to update it once a minute because we did the math and now it can last 20 years without wearing out. And people get that wrong all the time, in particular if they're used to working on desktop machines, which this is less of an issue.
Yeah.
So people get this. This is a classic embedded system mistake, is to update something periodically and wear out the memory. And it happens and it happens and it happens. And it sure smells like it happened again.
That's too bad. When do we get a fix, Michael?
The folks are going to get, wow, this is a long 573.
Yeah.
It looks like owner notification is going to be in late October or early November. I think that they are up. They're going to inspect your vehicle because I think they need to determine whether or not you still have the ability to continue using that combination meter for a period of time, and they could just upgrade the software, or whether you need to get a new combination meter.
Well, if you upgrade the software to write it less often, it doesn't change the fact it's mostly worn out.
Yeah.
They're going to have to replace that. Yeah.
Yeah.
Okay. Next up, Michael lied to me. This is Polestar, 27,816 vehicles. The 2021 to 2025 Polestar 2. The rear view camera display may have visualization issues during a backing event.
Yeah, this is number 48. I think 48 or 47th rear view camera recall of the year. So the owners of these are probably going to hear about this in early November. NHTSA was working, it looks like, in the background with Polestar since August. And so pressuring Polestar to do something here. But it looks like they proposed a remedy to NHTSA, and then they looked at their remedy and said, oh, that's not going to work. So they're still going through an engineering analysis here to figure out what's going wrong and how they're going to remedy it. So that November date for the planned remedy may or may not be fixed. So owners should keep on top of that one.
But let me make a slightly cynical comment about the remedies, because I told you about my Volvo rear view camera. The fix was to replace the camera. And what would happen is, by the time they replaced the camera, the car had been inside a garage and cooled off, that it worked just fine. And then the next week it would start failing again. And at some point I got tired of going to the dealer to replace a camera that wasn't fixing the problem. So the fix is not always the fix.
Right. And they note further down here for owners that it is expected in the first quarter of 2026, maybe the second quarter. So this might be a recall that drags out for Polestar owners. So hopefully you have the Polestar model that does have a rear window, as we talked about a couple of weeks ago, and you have mirrors that are effective, because you're probably going to need them if you experience this problem.
Right. All right. Last recall. Ford, 101,944 vehicles. The 2016 to 2019 Ford Taurus. Oh, we have the driver and front passenger door B pillar trim may detach from the vehicle while driving. For a Ford recall, that's not too bad. It's more of an annoyance.
Yeah, they've had a few of these trim detachment issues. A lot of manufacturers seem to have lately. I think even Hyundai even had one this week. I think it was the gas cap or the electric port cover or something flying off. But we've seen a lot more of these detached parts flying around and causing safety hazards in the last few years. And I don't know if that's because there are more parts flying off of cars, or just because NHTSA has gotten better at enforcing and requesting recalls on these kind of issues.
Well, also there's the ramp up in the use of glue.
Oh, yeah.
I mean, there's glue all over the place on these things. And an interesting question I don't know the answer to is what are the fraction of joined components that are held together by glue? And it could be that's going up. Certainly that's gone up since 20 years. And the question is just, are we just sort of seeing the cars get old enough that the glue's fatiguing and breaking off?
Right. Or are they switching their formulations for glues? Go back to
or maybe they used the wrong formulation. Maybe they used the wrong formulation and it looked good for a while until it didn't, right? There's a lot of, or the other thing with glues is you have to have a really tight mechanical tolerance for these things to work, because a lot of glues don't span voids.
Right.
And so if you have gaps that are too big between the components, the glue might not work as well. There's a lot. I'm not a material scientist, but there's a lot going on there.
Yeah.
Right. And especially in an environment where the temperatures fluctuate so greatly.
Right, because now you have dissimilar materials expanding, contracting at different rates that are putting shear forces on the glue. I did actually take a couple mechanical engineering courses, it turns out. I went to the old school where they beat on us with all these strength of materials course and all this other stuff back in the bad old days, stone knives and bearskins and, the whole thing.
That's great. Pay attention to our next podcast, Glue, not just for sniffing. And with that, that's the end of our show. Thank you so much, Phil, for coming by and being our new Fred.
My pleasure. Well, I could never fill Fred's shoes, but I can, I don't mind pinch hitting for him when he's off at the Piggly Wiggly doing his errands.
Yeah. Oh, look at that. Wins again. Great.
You bookended with Piggly Wigglies this week.
Yeah. Seriously, the deep dive into rear view cameras, it made my heart warm.
Did that change your whole?
I just got tired of you guys going on about this, so I figured I'd come.
Yeah, it still bothers me, but now I understand better why it bothers me.
Fair enough. Yeah. That's all I can ask.
Bean counters. All right. With that, we'll be back next week. Take care, everybody. Bye.
Thanks, everybody.
All right. Thanks.
For more information, visit www.autosafety.org.